Okay, so for the rest of your life, you're going to know, at least until the course is over, that K sub W equals K sub A times K sub B. Now, let me show you a typical Berg exam problem involved with this, okay? Given the K sub A for acetic acid, by the way, you're going to see the symbol a lot. So AC stands for acetate, and so HAC would be the symbol for acetic acid. We use that a lot as the typical weak acid, so that's what this is. Okay. Now, given the K sub A for acetic acid is 10 to the minus 5. Okay. Now, below it I've written down the reaction it stands for. So you take the weak acid, you knock off the acid hydrogen, and here's its conjugate base. So that is the reaction that goes along with that K sub A. Okay, now, knowing that, can you calculate K sub B? Da-da-da-da. We're going to use the top equation. So K sub B equals K sub A divided, K sub B equals K sub W divided by K sub A. So look at the top equation and notice what I just rearranged it algebraically. Now plugging in some numbers. So K sub W you're always going to know is 10 to the minus 14th. In this problem, the K sub A was 10 to the minus 5. Divide 10 to the minus 14 by 10 to the minus 5, you get 10 to the minus 9. So it's really cool is by knowing one K, we're able to actually calculate another K. So that's usually question number one I ask you is if you know K sub A, can you calculate K sub B? Can you handle it? Answer yes. Okay. Now here's question number two. Can you name B? Can you name the base? Well, the base must be the conjugate base of acetic acid. So go back to the reaction. If HAC is the acid, acetate must be its conjugate base. Now here's question number three I always like to ask, and that is, write the reaction for the K sub B for acetate. And here's how it goes. You take the base acetate, you put it in the water, you do a Bronsted acid-base reaction pass, and so what do? You get HAC, and you're going to get hydroxide. Now, you want to keep this in mind. That is really the proof to you that really have the right reaction. If it's a K sub B reaction, you should always end up with base. You should end up with hydroxide. Okay, now here's what I want you to do. I want you now to try this one. So given the K sub A of HF is 7 times 10 to the minus 4, okay, I want you to answer these three questions. Okay, so calculate K sub B, name the base, and then write the reaction. So I'll give you a moment to do that. The answers will actually be on the next sheet, which I hope you don't look at yet, but so I'll give you a moment to see if you can answer these questions on your own. Okay, let's see how you did. Okay, here should be the answers. Okay, so K sub B is equal to K sub W divided by K sub A. Why is that? Because K A times K sub B is K sub W. Okay, so you know K sub W. I hope you know that the rest of your life, 10 to the minus 14. And the problem gave you the K sub A of 7 times 10 to the minus 4. And let's see if my calculator is any good. I get an answer of 1.4 times 10 to the minus 11. Let me try that. So 1e 14 minus divided by 7e 4 minus, again, it's answer of 1.42 times 10 to the minus 11. Okay, now name the base. Well, the base of HF ought to be F minus. And now question three, what reaction are we talking about? What's the K sub B reaction? It'd be fluoride and water, do a Bronsted acid-base reaction, so you get HF, and the double check is you should get hydroxide as the conjugate base of water. Okay, now I'd like you to notice something kind of cute. If K sub A times K sub B equals K sub W, it means these two quantities are inversely proportional. If K sub A goes up, K sub B goes down. Notice it ties in with our Bronsted theory. Remember, in the Bronsted theory, I gave you a list of acids, and the acid strength as you go down, they get weaker. But for the bases, it's the opposite. Kind of makes sense. So if the acids get weaker, the bases get stronger. So they are inversely proportional to each other. Okay, I want to do one more with you. Given the K sub A for HCl is infinity, let's answer the three questions for HCl. Okay, first of all, what's the K sub B? It's K sub W divided by K sub A. Okay, what's 10 to the minus 14 divided by infinity? I don't think math teachers like to talk about it, but it doesn't bother us in chemistry. It'd be a big fat 0. Now, can you name the case of B of chloride? Of HCl, it must be chloride. Okay. Now, can you write down the reaction we're talking about? The case of B reaction must be chloride into water. Okay, so you do a Bronsted acid-base reaction, gives you HCl and hydroxide. Now, why did Berg put a red line here? Because the fact that 0 means this reaction does not take place. Now, we have a very special name for an ion that does not react with water. It is called a spectator ion. So chloride is a spectator ion. Now, you will do yourself a giant favor if you will memorize the key spectator ions. So look on the right side right here. It's really a nice trend in terms of the periodic table. So the members of family 1A, the positive ions from family 1A do not react with water. They're spectator ions. So that'd be, for example, sodium, potassium, lithium. When you put in the water, they do not react with water. Same thing on family 2A, like magnesium, barium, strontium. Okay, they're all members of family 2A. Their positive 2 ions do not react with water. Now, it turns out, notice I go from family 2A all the way to 8A. It turns out the rest of the chemicals on the table, most of them do react with water. They're not spectators. But family 7A, okay, the negative ions are all spectator ions except for fluoride. So that's why I've written fluoride with a slash. Fluoride actually does react with water, but the rest of them, chloride, bromide, and iodide, are spectator ions. Now, in addition to these 3 generalizations, I want you to memorize that nitrate also is a spectator ion. Very important. You might have noticed in the chem lab, we use a lot of nitrates in doing chemistry. And one reason for doing that is because we know nitrate isn't going to complicate things. It does not react with water. Now, this is going to be a very important generalization for our next lecture, which is going to be on Tuesday. Just kidding. You have vacation next week, okay? So a week from Tuesday, our next lecture, we're going to pick up on this a lot. Okay, are your brains full? Enough chemistry for one day? Say yes. Supposed to say yes. Okay. So let me get back to the original screen because I want to show you a homework problem. So here's the homework problem I have for you. Okay, this is a polyprotic acid, H3PO4. Okay. And I want you to see if you can calculate. It'll have 3 case of A's, case of A1, case of A2, and case of A3. You need to look these up. You could probably find them in your textbook or find them online. Okay, and I want you to start off with 10th molar and figure out the concentration of all species and the pH. So let's see, what are the species? You're going to have H3PO4, H2PO4 minus 1, HPO4 minus 2, and PO4 minus 3. Okay, because you haven't lived until you've done a 3-acid polyprotic acid. Okay, so everyone, have a great vacation.